Hello grade 9 students. Today I am here to teach you chapter 14 in your textbook, that's Loci and Constructions. This is an important lesson because you are getting one question in the O-level exam. So here loci. The plural form is loci and we call locus. What is locus? Just path. Now think about your throwing a stone. The stone travels like this. When you drop something from up, it comes down like this. So when you run along the running path, so you are going along this. So these are paths. But in this lesson, we are not considering paths of an object in the space. We are considering paths of a point on a plane. So we'll see what are paths you need to learn in this lesson. A locus means locus is a set of points satisfying one or more conditions is known as the locus. So path of a point. So let's take the point is P. If the point P travels from A to B, so these are the points of P. So it goes along this and comes here. So what's the path of the point P there? It's a straight line. So this path is a straight line along AB. We'll take a curved one here, curved line, C to D, curved path. So what's the locus of this point P? So it travels along this to D. So this is a path. So it's a curved line from C to D. In this lesson, you will learn 4 basic paths, and these should be repeatedly learned till grade 11. So you have to do this grade 10, grade 11 as well. So you are learning 4 basics, and here we are using compass and the ruler. Why? Because it says construction. Construction and draw is slightly different. Draw, you can use protractor, set squares, ruler you can use. But constructions, you are using only the compass and the ruler. The first basic loci you have to learn. What is that? The locus of a point which are at a constant distance from a fixed point. So what are the guided geometrical principles? There should be a fixed point. So assume this is a fixed point. The rest of the points should be a definite distance away from a fixed point. So in this case, it's given mark all points 4.2 centimeter distance away from this point O. How can you find out the path? Okay, so let's take the z square. This is one of the set square in your geometrical set. So we'll take that, and here we need keep this on top of this point. So here 4.2 means somewhere here. So here starting value 0, 4.2 is here. Okay. So what I'm going to do, I'm rotating this one and get the other point. Okay, you can mark 4.2 here. And so you can't change the position, just rotate 4.2 here. 4.2 here. So I'm rotating and try to get the path of point away, 4.2 centimeters away from O. So I'm marking all 4.2 distances. Now, when you take these paths, now here, so here this is not a point. Now what can you see? What's the shape? So here, when you draw all these points, what can you get 4.2 centimeters away from O? You will get a circle. So what's the locus of a point on a plane which are at a constant distance from a fixed point is a circle. Now how we are going to construct this? So you can use, without taking the set square and measuring, there's an easy way. So how you do that? You can take the compass. So we'll use the compass to construct that. Okay, so here I'll erase this and try to draw it again. So here, this is not how we need to construct. Okay, I'll erase this. Now take the compass, okay, and measure 4.2 centimeters. So 4.2 centimeters with your ruler or set square, doesn't matter. And then you keep on top of this O point and you draw the circle. So now see, so this is the path of a point a fixed distance away from that point. So it's a circle. So how you describe this? You can describe this locus as the center O and radius. Radius means the distance from here to here. You can say distance is 4.2 centimeters and radius 4.2 centimeter circle. So this is the first loci you need to know. Now take this one. The diagram shows a design consisting of squares with each side is 1 centimeter. So I'm assuming this one is 1 centimeter. Using a compass, construct a circle with center O and a distance of 2 centimeter from the center, which is the locus of point P. So 1 square centimeter means 2 squares, 2 centimeter. So we need to now take the compass and keep the compass on top of the fixed point O. That's the fixed point. And take this distance. So this is 2 centimeters. Now what we can do? We can draw the circle. So we'll draw the circle. So that's the circle with center O and radius 2 centimeters. So the radius is 2 centimeters, this length. So how you describe the locus point? a circle, locus of P is a circle with center O point, and radius 2 centimeters. So that's how we describe the locus of a point. Take this one. The diagram shows a design of 25 squares with each side 1 centimeter. So 1 centimeter each. With the help of compass, construct the path 3 centimeters away from A and situated inside the square ABCD. Now A is here 3 centimeters away. So that means 1, 2, 3. So this should be the radius. Now we'll take the compass, keep on top of A and take this distance. This is the radius now. Now we need to construct the locus 3 centimeters away. So you can draw this. So inside means only here. Don't construct outside the squares. Then using this compass, construct the path 3 centimeters away from point B and situated inside the square ABCD. We'll take now the center is B. So center is B. We'll take it. Keep on top of B and 3 centimeters away. So 3 centimeters away means again here this point. This is 3 centimeters away from B because we can take 1 centimeter, 1 square. Now we'll draw that path. So that's the other path. This is also 3 centimeters away. Mark P as the point of intersection of above 2 paths. So they are asking to mark the intersecting point of these 2 paths is P. Take this one. ABCD is a square with each side is 6 centimeters. So one square is 1 centimeter. O point bisects AB. So that means equal distance, 3 squares here. Construct the path 3 centimeter away from O. So what you do, this is the center now. So take the compass, keep on top of the center O and the radius becomes the either OB or OA, 3 centimeters away from that. So this is the radius and now we can draw the locus. So what can you say about this? This is 6 centimeters whole thing. So what's the radius now? Radius is the 3 centimeter length. So what's the locus here? Locus is the, so this is anywhere you get the point P. Locus of point P is a semicircle now because this is inside the squares, not a full circle. Is a semicircle with center O and radius 3 centimeters. Take this one. ABCD is a square with side 6 centimeter. Construct the path 4 centimeter from A and inside the square. Okay, so we'll take 4 centimeter means 1, 2, 3, 4. This is the point. So we'll take the compass and take this distance is the radius now. So 4 centimeter inside the square. So we can construct up to here. That's the path of this one, first part. Now second part, construct the path 4 centimeter from B and inside the square. So 4 centimeter from here now. So we'll take the center now B. 4 centimeter means now 1, 2, 3, 4. 4 centimeter is now here. Now we can construct the path. So that's this one. Then shade the common area bounded by the two paths, equidistance from A and B or at a lesser distance from A and B. Now when you take these two, this point means, in the intersection point means the distance from A to here or B to here is equal. When you take any point in this region, what's the distance? Distance is lower than that. So that's why they are mentioning the equidistance from A and B or at a lesser distance. So this is equal or lesser. So this is the required region. Now you need to learn the second basic loci. The locus of points which are equidistant from two fixed points. So what are the guided two geometrical principles? The 2 points are fixed and equidistant from both points. Let's take this one now. If you know there's a coconut tree and a jack tree, you know those are fixed. So this is coconut tree, jack tree. And we know that there's a hidden treasure equal distant to these two trees. So how can you get the treasure? So one will say, okay, we'll connect the two trees like this and take the middle one. Do you think you can get the treasure? No, because somebody will say, okay, I'll go this way, equal distance from here to here. This is also equal distance, here to here or here to here. So when you take equal distance from the two fixed points, you will see there are so many points. So what you have to do to take the treasure? You have to dig along this line. So we don't know, it can be here, here, any place along the line. When you connect any point on this line with these points, the distances are equal. So what is the locus of two fixed points with equidistance from the 2 points? That's a straight line, and we call this is the bisector, perpendicular bisector, because it will, here when you measure the angle, this is 90 degrees as well as This is equal distance. So we call this is as the perpendicular bisector. So now we'll see how we can construct the locus of two fixed points with equidistance to those points. Take this one. A and B are two fixed points, 12.5 centimeter distance from each other. Okay, so we'll first mark the 2 points. I can first take the ruler and mark a line. And then how can I mark 12.5 centimeter 2 points? I can take the compass and the ruler. I can measure 12.5 centimeter distance from here. So 12.5, I'll extend this. So I'm getting 12.5. So somewhere there, 12.5. So I can take the compass. From any point, I can just mark a point with an arc, small arc. I can highlight, that's 1 point. Then what I can do, I take the compass to this point and mark again the other place with an arc. So here I can keep like this and mark the other point. So that's the 2 points, A and B, with 12.5 centimeters away. So those 2 points are fixed. Now what you have to do? Construct the locus of a point P which is equidistant from A and B. So we know that's the perpendicular bisector. So how we can draw the perpendicular bisector? So I'll show you how to do that. Take the compass. So keep on 1 point and take more than half of this. Just take more than half of this length. Is okay now? More than half. Then what you do? Keep on top of this, and here you have to keep it there, and you can draw an arc here. Then you take the compass to this side and same length you draw an arc below as well. Now take the compass and keep on top of the point B, and you can take the same distance and mark the arc here as well as arc down. Now we got 2 intersecting points. So this point and this point. So we need to connect those 2. So take the ruler. You need to keep it on top of these 2 points. Here, this point and this point, and then draw the line. So I can draw the line, passes through these 2 points. So this is the bisector, perpendicular bisector of the 2 points. So here we can see this is 90-degree angle. So when P and Q are connected, so we'll take this is P point and this is Q. The distance from A and B to any point on the line PQ equal. So here to here, that's equal. And when you take any point, you get equal distances. We'll check that one. So think about, this is the diagram. We'll measure it and see whether you get the same distances. So 2 fixed points, and this is the perpendicular bisector. Now we'll measure. So take z square. It's easy to take the z square to measure because you can rotate it. Okay, so here first we'll measure here, this side, here to here, AP3. What's AP3? AP3 is 6.3. Now see, keep on top of this and measure AP2. That's 6.5. That's AP2, 6.5. And then measure this one, AP1. I'll extend this. AP1 is 7.6. And AP4 like 7.2. Now what we can do, we can measure the other side, BP1. We'll measure these lengths, BP1. I'll keep here. What's the value? Here you get 7.6. So I'm getting BP1 7.6 centimeters. Now measure BP2. What's the value? Here 6.5. I'm getting this is BP1, BP2, 6.5. Then BP3. BP3 6.3 centimeters, and BP4 value 7.2. BP4 7.2. Now look at these values and what can you say? These two are equal. AP1 is equal to BP1. AP2 is equal to BP2. AP3 is equal to BP3 and AP4 is equal to BP4. So when you take any point on the perpendicular bisector, you get equal distances to the fixed 2 points. So what's the locus of points which are equidistant from 2 given points? Is the perpendicular bisector of the line joining the 2 points. Take this question. Shown below is a design of 6 by 6 square. In this diagram, mark 9 points equidistant from A and B join these points by a straight line. So 9 points equidistance. Now this is 6 centimeters. So what is the midpoint? 3 centimeters away. So 3 centimeters away I can take, this is 1 point. So again if I take here, that's another point like that. So here you can mark like several points, 9 points, and what you do, you can connect all the points with a ruler. So take the ruler and connect all these points. That's the perpendicular bisector of A and B. In the square design shown below, mark 7 points equidistant from A and B and then join these points. So this one, what's the midpoint? This is the midpoint. So when you take along these diagonal points, these are the equidistance points to A and B. Now we can connect all these points with a ruler. So this is the perpendicular bisector for AB line. Now you are learning the third basic loci. So what's the third one? The locus of points which are at a constant distance from a fixed line. Now there's a fixed line. So what are the guided two geometrical principles? Straight line must be fixed and should be equal distance from the straight line. Now take any straight line like that. Take any straight line. So this is fixed. So we want to find out 3 centimeters away from that, the locus of this straight line, 3 centimeters away. So one can take 3 centimeters away. Okay, so this point. Another one, this point. So like that, when you take these points, you get a straight line. So you get another straight line. But another person can take this side, 3 centimeters away, this side. So another line. Three centimeters away from this. So what you get? You get 2 parallel lines. So this is fixed. So 2 parallel lines 3 centimeters away from that. So we'll see how we can construct that. The side of the square ABCD is 6 centimeters. So 1 square means 1 centimeter. Mark several points 2 centimeter distant from straight line XY. So 2 centimeter here. This is 1 point. This is another point. So these are points 2 centimeter away from the XY line. Again, I can mark this side as well. On this side, I can mark these points. That's also 2 centimeters away from XY line. So when you connect all these points, what you get? A straight line, 2 straight lines parallel to XY. So this is parallel here. So these points are on both sides of XY. Join all these points. Locus of the point P are the 2 parallel lines drawn on both sides of the given straight line at a distance of 2 centimeters. This is 2 centimeter and this is also 2 centimeters. So here, what's the third one? The locus of points which are at a constant distance from a straight line are the two straight lines parallel to it and at the given constant distance from it on either side of it. So you have to consider on both sides. Take this one. ABCD is a 6 cm by 6 cm square. Construct the locus of point P 2 cm distance from straight line MN. Describe the path. So MN 2 centimeters away, either this side or this side, you can get any point here. Here also 2 centimeters away from MN, you can get these points. When you connect all these points, what you get? It's a parallel line to MN. So you get two parallel lines on both sides of MN. So what's the path? This is parallel, you can mark it. This is 2 centimeters away from that. So how you describe the path? Two parallel lines to MN on both sides 2 centimeters away from MN line. So that's the locus of a line a certain distance away from that. Now the last basic loci point you have to learn. Constructing the angle bisector. Angle bisector means angle is equally divided into two parts. Here you should be guided by two geometrical principles. The two arms of the angle should be both fixed. So AB and BC both fixed, should be an equal distance from the two arms of the angle. So when you draw the bisector, equal distance. So we'll see how we can construct the bisector. So construct the locus of P at an equal distance from AB and BC in ABC angle. So how we can construct that? So you need the compass. So take the compass, you can keep on top of the point B. That's the angle, B angle. Then take any distance. Take any distance. And then you mark an arc on one arm AB and take the same distance, don't change it, and mark the other arc. Then take the compass to those points and you need to draw an arc in the middle, because the angle bisector means equal distance, not towards AB or BC. It should be in the middle. So somewhere there we can mark this arc and then keep the compass on top of this point and you can mark the other arc. Now we can connect this point and this point with a ruler to get the angle bisector. So you can take your ruler, keep on top of the B point and on top of this intersecting point. Keep correctly, and then you can draw the line. So I can mark the line like this. So you can mark it. So that's how you get the angle bisector. So when you take any point on this line, the perpendicular distance from any point with this one is always equal. So when you take another, so any distance, so if you take another point, so perpendicular bisector, so when you take something like that, this distance is equal to this distance. So this is called the angle bisector. So that's your fourth basic loci. Now there's an angle, so we'll construct the angle bisector. So how you do it? Again, take the compass, keep on top of B, take any distance from here, any distance, and you can mark an arc here. Again, take the compass down and mark an arc on top of BC. Take the same distance here and you can draw arc in the middle and keep here and another arc in the middle. The intersecting point with B you can connect with a ruler. So I'll connect with a ruler. So that's called the angle bisector. This angle is equal to this angle. So the locus of points which are equidistance to two arms, an angle, two arms of an angle is the bisector of the angle. So equidistance line is the angle bisector. Take this one. Mark the path of point P which is equidistance from arms OX and OY subtending XOY and explain the path. So that means we need to bisect this angle. So 90-degree angle we need to bisect. So we'll take the compass and do. So take the compass, keep on top of the angle, that's O here, and then take any distance, you can take any distance. Mark an arc here, arc on the other side. These are two arms, OX and OY. And then take the compass and keep on top of this point. And in the middle, like, you need to draw the arc. And keep on top of this point and draw the arc. And here we get the intersecting point and take the ruler and connect from here to here. So that's the angle bisector of O. So what's the path? You can describe the locus. So this is P. Any point on this line is the path of point P. So point P is on this line. So what's the locus? You can write angle bisector of which angle? XOY is the locus of point P which is equidistant from arms OX and OY. Take this diagram. Mark the path of point P, which is equidistant from arms AB, this one, and ABC, subtending ABC angle, this angle. So here we can see this is like here equal distance from here to here, and again this point I can mark. I can mark this point here, here and here. When I connect all these points, I can get this line. So what's the path, locus of point P? Is the angle bisector of ABC. So you can write the locus, point of locus of P. Point is the angle bisector of ABC. Let's take this one. Using the compass, construct the locus of point P, which should be equidistant from the two arms KL and LM, subtending the KLM angle. So that means we need to construct the angle bisector. So you need the compass. Whenever you construct something, you need to take the ruler and the compass. You can't take the protractor or set squares for that. So what you do, take any distance, mark a point there with an arc, here on the other side as well. Then keep on top of this point, the intersecting point, and in the middle you draw an arc and keep on top of this point and draw the other arc. You can't change the position, so you have to draw the other arc. Now there's an intersecting point. You can connect with this point and here with a ruler. So that's the angle bisector of KLM. So when you take this angle and this angle, both are equal. Now take this one. Using the compass, construct the locus of point P, which should be equidistant from the two arms XY and YZ. So that means you have to construct the angle bisector of Y angle. Here, now it's down, not the reflex angle. Okay, so take the compass and keep on top of Y, and you can take any distance from that and you can draw arc here and arc here. Then take the same distance, keep on top of this point, and you can mark the arc in the middle and take the compass to the other side and mark the other point. Here you can mark it. Now we have the intersecting point. Connect this one with a ruler. So here to here with a ruler. So that means this is the angle bisector. This angle is equal to this angle. Geometrical constructions. Now we'll see how we can construct a straight line segment. So you need to use compass and the ruler. So AB is 7.5 centimeters. How we draw? First you can draw a long straight line. And then adjust the compass to 7.5 centimeters and draw an arc. So draw an arc. Draw an arc on the straight line and mark the point B. So we'll take the compass and the ruler. So what's the distance? 7.5. So you take the compass, keep on top of 0 point. Now take the distance 7.5. Here, that's 7.5 length. And you can keep this on top of the line and just mark 1 point. And then what's the other one? Keep the compass on B with the same distance and mark the point A. So now we do take this point and mark the other point A. Now we got 2 points, 2 centimeters, 7.5 centimeters away. So this is point A, this is B, and this is 7.5 centimeters. So that's how you can construct a line segment. Draw a straight line PQ 8.1 centimeter long. So what you do, take the ruler and draw a long line, and then take the compass and the ruler, measure 8.1 centimeters using the compass and the ruler. 8.1. And then you can mark there. So you can mark this point and keep on top of this point, and you can mark the other point on this line. So now we have 2 points. So what's the line? PQ 8.1 centimeter away. So that's how we can draw or construct a line segment. Constructing a perpendicular bisector on a given straight line. Draw AB 7.2 centimeter straight line segment and construct the perpendicular bisector. So we'll do it. We'll draw a line. Now 7.2 centimeters. Use the compass and the ruler. Measure 7.2 centimeters. 7.2 here. Then keep on top of the line. You mark 1 point there and take the compass to the other point and mark the other point. Now we have 2 points. That's A, B. That's 7.2 centimeters. Now you have to construct the perpendicular bisector. So what's the method? You take the compass, take more than half of this distance. So you can take like this amount, more than half, and keep on top of 1 point, and you draw an arc above as well as arc below. Then keep on top of the point B and you can draw an arc below as well as above. Now can you see? We can't see the intersecting point. So what you do? You have to again draw this arc. So keep again with the same distance here, and then you can mark it from here to here. Still we can't get, so we'll redo the other arc as well. So I can extend this arc like this. Now we have two intersecting points. Take the ruler and connect this point to this point. So I'll connect here. So that's the perpendicular bisector of AB point. The distance from AB is 7.2 centimeters. The perpendicular bisector shown above is also the locus of the points equidistant from the points, the fixed points A and B. So the equidistance point is the perpendicular bisector. Construct the perpendicular bisector of XY line. Already given the 2 points and you need to draw the perpendicular bisector. So what you do? Take the compass with the distance more than half of this line, XY point, more than that. And then you draw an arc above and below. So don't change this point, you can mark it below. And then same length you keep on top of the other point and you can mark it. So here you can mark here, and I have to mark the above as well. Now here also I can't get the point. Here intersecting point is not clear. So make sure that you redo that arc again. Here I can extend this one. Here I can extend this line like this. Now we have 2 points. You can connect these 2 points with a ruler. So that's the perpendicular bisector of XY. Construct the perpendicular bisector of straight line MA. So same thing. You take the compass, keep on top of 1 point, take the distance more than half of it. So you need to take more than half of it, somewhere here. And then you draw an arc above and below. Again keep on top of end point and then draw the arc on the other side, below and up, till you get the intersecting points. So then you can connect those 2 points with a ruler. So I can connect these 2 points with a ruler. So this is the 90-degree perpendicular bisector of MN line. Construction of a perpendicular at a given point on the straight line. So we'll take this question. Draw a straight line AB of length 11.5 centimeters. So first we'll do that. Draw any line and take the ruler and the compass. What's the distance now? 11.5 centimeters. So you measure 11.5 centimeter length from this one, 11.5. Here, 11.5 centimeter. So you take the compass and keep on top of the line and mark the 2 points. This one, and again keep it on the other point and mark this point. So that's the AB line. That's 11.5 centimeters. Mark any point P on the straight line and construct a perpendicular at point P. So the P point is on this line. So I can mark here. P is on the AB line. I need to now construct a perpendicular to AB at P. So how I can do that? You need the compass. So here you take any distance, very small distance enough. So you keep on point P, take any distance here, and you need to mark 2 points on both sides. Any distance, no need to be AP distance. So any distance from P, take the same length. Then you take a bigger length than that, and keep on top of this point. And you can draw the arc above and below. Then what you do? You take the compass and keep on top of the other point you marked. So this one. And you can draw the 2 arcs below and above. Now we have the 2 intersecting point and you can connect it. So sometimes you don't need the below one because you know the point P. You can connect to P point. It's better to take a below point as well. Then we know exactly this is passing through the point P. Here when you connect these 2 points, you can see this is passing through point P as well. So this is the perpendicular drawn to point P. So what you do, first you have to mark equal distance point from P and then take those points to draw the other arcs above and below. Construct a square ABCD having a side of 6.6 centimeters. So what you do? 6.6. So you draw a line and you need to measure 6.6 centimeters. So for that, I need the compass and the ruler. So take first 6.6 centimeter length. I can take 6.6 centimeter length and mark it here. So I'll mark it here and keep again on top of this point and mark it here. Then those are the 2 points. Now what's the property of a square? Now we need to construct a square. We know that all these angles are 90 degrees. So that means if we can draw perpendiculars to these 2 points, you can find out the other 2 points. So to do that, you can take the compass to draw the perpendiculars to these 2 points. So take any distance, small distance is enough. So you draw an arc on one side and onto the other side. You can do the same thing to the point B. The other point, we'll take B point there. This is A and this is B. Do the same thing now. So keep on top of B and you can mark here and to the other side as well, another point. And take a bigger length than the other one. Keep on top of one point here and you can draw the arc above. Here you don't need to draw the arc below. So we'll take only above. So you mark these points. And then again, keep on top of this arc, draw an arc above here and again on top of this and draw the other arc. Now we have 2 intersecting points. Now take the ruler and connect this point and this one. And here this point with this. Now we have 2 perpendicular lines. So that this one 90 and this is 90. Now we know square, all sides are equal. So all sides are equal means you need 6.6 centimeters. So with the compass, we can take again 6.6 centimeter length. 6.6 centimeter length. And keep on top of the point A and mark the point here. Again, keep on top of point B and mark here. Now we have the other 2 points. So what are the other 2 points? A, B, C, D. When you are marking, you have to go either clockwise or anti-clockwise. A, B, C, D. Now we can take the ruler, connect these 2 intersecting points. So we get the ABCD square. Each side is 6.6 centimeters. So all these sides are equal. So that's how we can construct a square. Construct a square PQRS having a side of 7.2 centimeters. So you need a ruler. Length is 7.2. So first draw a bigger length and then with the help of the compass measure 7.2 centimeters. And then you can keep on top of the line, mark one point, and on the other side also you mark the other point. So that's the PQ point, that's 7.2 centimeters. Now you have to draw the perpendiculars to P and Q. So you need the compass and mark arcs with same distance. Now take a small arc length. You can draw an arc here, an arc onto the other side. So do the same thing for the Q point. Arc on one side and the other side. Now take a bigger length. Take something like this. So you keep the compass on top of these marked arcs and draw the arc above. Here also you can mark it. Do the same thing for this point. Then you can connect with the ruler. So I can connect P point and this one, Q point and this one. Then you can measure again 7.2 centimeters and mark the point. So 7.2 length. So keep on top of P and mark the other point here and here. So those are PQRS points. So we can mark PQRS and then with the ruler you can connect this point and this point. So that's the PQRS square. You can do this with a set square as well. If you are doing with a set square, how you do it? You take the set square and here you can see 90-degree angle here. So here what you can do, after you construct the 2 points and the line, one line, you can keep the set square correctly along with the PQ line here and draw the line here, and then again what you can do, you can move the set square here and keep on top of the line PQ here, and this should be on top of point P, and then you draw this line. Then you mark the 7.2 centimeter line and connect. That's also another way of constructing the PQRS square. Construct a rectangle ABCD with AB 7.5 and BC 5.9. Now, a rectangle. Only difference is you get two sides equal, not all sides are equal. Pair of opposite sides are equal. So, same thing. So, what's the bigger length? 7.5 will take along this line. So, draw a line and with the help of the compass and the ruler, we can measure 7.5 centimeter length. 7.5 centimeter length from here, and keep on top of this point, this line, and you can mark one arc here and another arc above the line. So those are the 2 points AB. So I can mark it AB, that's 7.5 here. Then what you have to do? you have to construct two perpendiculars to point A and B. So to do that, you need the compass again. So I'll take another color. Take the compass. Keep on top of point A. Take any distance. Mark an arc on one side and another one on the other side. Take point B, an arc on one side, an arc on the other side. Then you take the compass again. Take bigger length now and keep on top of these two pink arcs and we'll take bigger length. So you can draw two arcs above. Here and keep it here and draw the other one. Do the same thing for point B. You keep on top of this and draw an arc here and keep on top of this point and draw an arc here. Then you connect the two lines. This one and this one. Then what you do? Now we have 7.5 centimeter length, but the other length is 5.9. Now you have to take the compass and measure 5.9 centimeter length. .9 centimeter length and keep on top of the point A and mark the other point on this line. This one. And again keep on top of B and mark it on the other line. Now we have A, B, C, D. So here this is C, this is D. Take the ruler and connect this point and this one. Now we have the ABCD rectangle. This length is 7.5. This length is 5.9. And these angles are 90-degree angles. Construction of a perpendicular from a point outside to a given straight line. So this is a straight line given. Now the point is above the line. Any point outside. Earlier we took a point on the line and we drew the perpendicular to that. But now from an outside point. So draw a straight line AB, mark a point P anywhere above the line, construct a perpendicular from point P to the line AB. So look at carefully how we can do that. So you take any length. So you keep on P, take any length and you have to mark two arcs on AB. So I'll take this one and when you take again you get another arc. So two intersecting points with the same distance from the point outside. That's your first step. Then what's the next step? You have to take the compass and take any distance from here, keep on top of the point here and you can mark an arc below, take the same distance from here and mark the other arc. Now, can you see? You get this intersecting point and the point above, you can connect it. So you can connect with a ruler. So take the ruler, keep on top of this point and P and connect it. So that's how we can construct a perpendicular from an outside point to a given line. So this is 90 degree. Draw a straight line MN, mark a point P outside the line, construct a perpendicular from P to line MN. So we'll take a different line, not a horizontal line, slant line like this. We'll take MN is that, MN. Now we'll take any point P here. Now we need to draw a perpendicular from P to MN. So what you do? You take the compass, take any distance, and here you need to mark 2 arcs on MN. So here one here, another one here. Now what we do, take the compass again, keep on top of this point. You can take any length and mark here. Take the same distance from N and mark the arc. Now we have the intersecting point and P, connect with a ruler. So this point and this point. Now we can see this is 90 degree perpendicular. So that's how we construct a perpendicular to a given line from outside point. Construction of angles. Now we can construct certain angles. 60, 120, 45, 90, 120. Certain angles we can construct. We'll see how we can construct. So what's the method? Draw a circle with center O. We can take the compass and just draw a circle. So we'll first mark the center. We'll mark a point and draw a circle. You can take any length and draw a circle. So center is O and we'll take any point on this is A. So the radius is OA. Taking the same radius, mark B, C, D, E, F points starting from A. So you can't change this distance. So take it to point A and you can mark on top of the circle. Here we can mark this point. Again, take it to this point and mark the other arc. All these lengths are equal to the radius OA. Again, mark this point here and another point. This one. Another point here. And when you take this one, you will get the same point A here. Now, draw AOB. So take the ruler, AOB. Now we can mark it first, AB, C, D, E, F. Those are the points around the circle with equal distance, and all the lengths are equal to the radius. Draw AOB now. Take the ruler, connect OA and OB. So this is AOB angle. AOB angle is this one. The circle has been divided to 6 equal parts. So what do you think about this one angle? 6 equal parts. 360 is the angle around a point. So the whole circle is 360 equally divided into 6 parts. So what is one angle? 360 divided by 6. So that's 60 degrees. So we'll see whether it's 60 degrees by taking the protractor and measure it. So keep on top of this line and we can measure it correctly. First, slightly above. You need to keep this line with the protractor line here. So here we can see this is 60-degree angle. So from above method we can construct 60-degree angle. So how we can construct 60-degree angle? With a circle, taking equal distance to the radius around the circle. Now we'll use another method to construct 60-degree angle. Now no need to draw the full circle. So we can think about equal distances all the places. Now when you take the previous one, this distance and this distance all are the same. What do you call that? It's an equilateral triangle. If we can construct an equilateral triangle, we can create 60-degree angle. So we'll take the ruler and draw a line first. So keep on top of this and draw a line. Then you need to mark the point A. So I'll take the pen and just mark point B, not A, because B is the angle there. So mark the point B. To this we need to construct 60-degree angle. So take the compass and take certain distance. We'll take any distance here, this distance. So you can't change the length. So keep on top of the point B and then you can draw an arc here as well as another arc somewhere there. So 60 is less than 90. So somewhere around here. So you can draw 2 arcs like that. Take the same distance, keep on top of this point and you can keep on top of this one and you can draw another arc like this. Now this distance and this distance, all 3 are equal. So this is the property of an equilateral triangle. We know in an equilateral triangle, each angle is 60 degrees. Now you can connect this one with a ruler. So this angle is 60 degrees. Bisecting a given angle. Bisect given angle ABC. So how can you bisect the angle? We did that before. Take the compass. this is the angle we need to bisect. Take certain distance. Draw two arcs here and here. And you can take the same distance. Keep on top of this point. And draw an arc in the middle. Here also arc in the middle. Then the intersecting point and the B point we connect. So that's the angle bisector. So this is the angle. So this angle is equal to this angle. Bisect PQR angle, PQR. So take the compass, take any distance, draw an arc on this arm and on the other side. And take the same distance, keep on top of this point, and somewhere in the middle, you connect it. And again, draw an arc like this, and what you do? Connect the intersecting point and Q. Take the ruler, connect Q and this point. It's not. Take Q and this point and draw the angle bisector of PQR. So this angle is equal to this angle. Constructing 120-degree angle. We did 60. If we can construct 60 and another 60, it's equal to 120. So we are doing that. If you want to construct 120, we can first draw 60 and another 60. So what's the angle? Q. So you mark Q first. So to this point, you need to construct 120 degrees. So take the compass. Take any distance from there. Don't change the distance. So you draw arc somewhere here and somewhere around here, because 60 means you know that's less than 90 degrees. Then what you do? Keep on top of this point and mark the other arc. Then what's the next one? Take the compass with the same distance. You keep now on top of the intersecting point now. And you have to draw another 60. So you can draw another arc somewhere there. Then keep on top of Q again and draw an arc to get an intersecting point. Now all lengths are equal. So 60, another 60. Now you can connect this one with a ruler here to here. Now this angle is 120 degrees, 60 and another 60. Constructing 90-degree angle. So like perpendicular bisector. Perpendicular bisector, that's 90 degrees. So we'll construct 90-degree angle. You need a straight line and mark the point where you need the 90-degree angle. We'll take this one. So to this point you need to draw a perpendicular. So what you do, you take the compass, keep on top of this point, take any distance and mark two arcs on both sides. And then take a bigger length keep on top of this point, and you can draw an arc above. Do the same thing for this arc. Keep on top of this and draw the arc. Now you have the intersecting point, and this point you just connect it here to here. Then that's 90-degree angle there. Construction of 90-degree angle using different method. So how you construct 90-degree angle? Think about 60 and 30. How you get 90? 60 and 30. You can do 60 and 30. 30 means angle bisector of 60. So you can use that method also to construct 90-degree angle. So we'll use that. Draw a line and mark the point. Now you need to draw 90-degree angle to this point. So we can construct 60-degree angle first. So take any distance and you can mark up an arc here and somewhere here. And we'll draw another one. We need another 60 from here. So we can draw somewhere here. Now keep on top of this point, and with the same distance you can mark here, and here we already drew that. From this point we can mark this point. Now we have 60 here and another 60. Now we need 90. So 60-degree angle we can connect with a broken line because we don't need 60-degree angle. So I'll just mark like this. That's 60. Now we need to take another 30 from here. Here this angle is 60. Bisect the angle. So what you do? You take the compass. Now you have already two arcs. No need to draw it again. You take any distance and keep on top of this intersecting point and draw an arc in the middle. Again, keep on top of this point and draw the other arc. Now that's the bisector of this 60-degree angle. Now when you connect it with a straight line, you get the 90-degree angle. Now this is 90-degree angle. How you got the 90-degree angle? This is 60 and another 30. So this is 90-degree angle. So that's how we can construct 90-degree angle in a different way. Construct 45. What do you think? 45-degree angle. 90-degree angle and then bisect it. You get the 45-degree angle. So we'll construct PAB. So that means A angle. Construct 45-degree. First draw a line and mark point A. That's the angle. Now you can first construct a perpendicular to this point. Take any length, draw an arc here, an arc there, and then take a bigger length and draw an arc above, keeping the compass on top of these two intersecting points. Now we have this one, so you need 90 degree now, so we'll take a broken line and then connect it with A. This is 90 degree, but we need 45. So how we construct 45? Bisect 90 degree angle. So take the compass. We need to bisect 90 degree angles. Take certain distance, draw an arc here and arc on the other side here on top of this line. Then take a bigger length or same length you can do. You need to draw an arc in the middle, arc in the middle here and another arc here in the middle so that you get the intersecting point. Now we can connect A with that. That's 45 degrees. So we'll take a straight line and connect here to here. That's 45 degrees. So this is 45 degrees. Bisecting 90 degree angle. Construct 45 degree angle using 60 degree angle. How can we do that? We'll see. Construct 60 degree angle to the point A. Then bisect 60 degree angle and get 30 degree angle. Bisect the angle between 60 and 30. We'll see how we can do. So draw a line. We'll say this is the point you need to construct the 45 degree angle. That's point A. Now take the compass. Take any distance. You draw an arc here, arc in the middle, an arc here. That's 60. Then 60 you need, this is the 60 degree angle. So we'll first connect this with a broken line because we need 45, not 60. Okay, then we need to bisect it first. Bisect 60, you get 30 degree angle. We already have the two arcs, so you need to mark the other two arcs to construct the angle bisector. Take any certain distance, mark here and mark here to get the intersecting point. Now we did that. So that's the 30 degree angle. So we'll connect that with a broken line again. Now this is 30. So how you get 45? What do you think? 30 plus 15. This is 30, this is 30. If we can bisect this angle, you get 15. 30 plus 15, it's 45 degrees. Now we'll bisect that angle. For that you need certain distance. And then mark an arc on top of the line, this line and here. And then you can take the same distance or different distance. It doesn't matter. And mark in the middle and here keep on top of this point and mark in the middle. Now you can connect this point and the intersecting point with a line now. That's the 45 degree angle. This is 45. How you got 45? This is 30 and this is 15. 30 plus 15, you get 45-degree angle. Bisecting 30-degree angle again. Take this one. You have given AB is 12.5 and construct 60-degree angle to point A. First we'll do the line AB. How you construct a line segment? You need the ruler and the compass. 12.5. So keep on top of the ruler. 12.5 is this distance. So you keep on top of the line. Here this point and here this point. So that's AB points. AB. What's the distance? 12.5 centimeters. Construct 60-degree angle to point A now. So this is the point. Take the compass and you can construct 60-degree angle. Take a certain distance. Mark arc somewhere here and here no need to draw it continuously, but you can draw somewhere here as well. Then you take the same distance from here and draw the other arc. So the intersecting point is the 60-degree angle 1. So you can connect this point with this intersecting point. Now that's 60-degree angle. Now you are asked to draw another 60-degree angle to point B as well. So we'll take the compass. Take any distance. Now not to this side. Here you have to select this way. Take certain distance and draw an arc here and somewhere there and take the same distance and keep it here and draw the other arc till you get the intersecting point. Now you can connect this line B with, you can connect B with this point. And here the intersecting point of these two lines should be the C point. So I'll redo this line again, connecting A with this intersecting point. Now it's okay. So what's the C point? C point is this one, intersecting point. So this point. Complete ABC triangle. So ABC triangle, this is 60, this is 60. So what is this triangle? This is also 60, equilateral triangle. Look at this one. The diagram shows a sketch of ABC triangle. Construct the triangle ABC to the correct dimensions. So you need to construct it. That means you have to construct 60-degree angle and here 6.9 length and 8.3 length. So take the ruler. First we'll draw the BC line. So you can take the ruler and the compass. Measure 8.3 centimeters. and keep on top of this line and mark a point here, and you have to take it other way around and mark the other point. So that's BC. BC with 8.3 centimeters. Then you have to construct 60-degree angle to this one. So take the compass. You can take certain distance from here. Mark an arc here, an arc in the middle, and then again keep on top of this point and mark the other arc so that you get the intersecting point. Now connect with the ruler B with this intersecting point. Then this is 60. This is 60-degree angle. Now we have to measure 6.9 centimeter length. 6.9 centimeter length from here. 6.9. Here. And you need to mark this distance. BA now. BA 6.9. So here you have to mark the A point. That's A point. This is A. This is 6.9 centimeters. So this is 6.9. This is 8.3. Now you can connect the 2 points A and C. Now you can see you get the ABC triangle. Now we'll look at example number 1. Draw a sketch of the locus of the bottommost point of the bob of a pendulum in a working pendulum clock. So here look at the diagram. This is a pendulum clock. So this is the bob. And here you are asked to draw a sketch of the locus of the bottommost point. Now here we know that it goes like this. So we need to draw this locus. So how we can draw? The locus relevant to this motion is a part of a circle with center is this one. Center, the fixed point of the rod or string to which the bob is connected, and radius, the distance from this fixed point to the bottommost point of the bob. So here to here is the radius. So what you have to do, you take the fixed point here. So we'll take, this is the fixed point. Take the compass and measure this length, whatever the length, we'll say this is something like this length. So what you do, you keep on top of this point and you have to draw a small arc like this. So here, what's the bottommost point here? This is the bottommost point. So here we'll mark it somewhere. Here is the bottommost point. So this is the arc. So if you want, you can connect this one with the ruler. So the here to here is the length of the string. Example number 2. Draw a rough sketch of the locus of points which are equidistant from the two given points P and Q. Name 5 points on the locus as P1, P2, P3, P4 and P5. So we need to first mark the two fixed points. Okay, we'll take this one is P and this one is Q. What's the equidistance from the 2 points? That's the perpendicular bisector. So we'll draw the perpendicular bisector. So what is the first step? Take the ruler and connect these 2 points. And then take the compass. Take any distance, but the distance should be more than half of this. More than half of this, and keep the compass here and draw an arc above and below. And also keep on top of Q point and draw an arc like this and arc here. Then you can connect these two intersecting points with the ruler. So that's the perpendicular bisector, and you can mark 5 points on top of that. Any point, you can mark P1, P2, P3, P4, P5. Any 5 points on the line. When you take any point on the line, the distance from P to Q, both are equal. Exercise 14.1. By a rough sketch, show the locus relevant to each motion given below. The path of a rubber bushing which is tied to one end of a rope of length 50 cm and rotated by holding the stretched rope at the other end as shown in the figure. So here look at the diagram here. So holding like this and rotating. So here they are asking what's the path. So fixed point is here, and the length of this string is the radius of the circle, and so you are rotating like this, so you get a circle. So to do that, you need 50 centimeter length. So this is a rough sketch, so we'll assume 1 to 10 scale will take. 50 centimeter is a long length, so we'll take 10 centimeters represent 50 centimeters. So we can draw a straight line first. And then you can mark here 10 centimeters because we can take 50 centimeters, 10 centimeters. So use the compass. (10 centimeter length). And then you can mark the other point. So this is the 10 centimeter length rope. So that's representing 50 centimeters. And holding here. So that means this goes like that in a circle. So how you draw that? You can take the compass, and here this is the arm. You take the radius as this distance and draw a circle. So you draw a circle there. So that's the path of the rubber bush. So you take, this is the any point on that path. So the radius is 50 centimeters here to here. Part B, the path of the tip of a hand of a working clock. So these are hands. So what happens? So this goes around and around. So you get a circle. So here you can take any point. That's the middle of the clock, the center. So you keep on top of that point, take the radius as the length of the hand. Take the length of the hand, we'll take certain distance, this is the length of hand, and it goes round and round like a circle. So this is the here to here. This is the length of the hand. The figure shows two houses located 50 meters from each other on horizontal ground. It is required to build a wall exactly halfway between the two houses, points A and B. Indicate by a rough sketch where the wall should be built. So that means that's the perpendicular bisector. Two fixed points are there. Equidistance to two fixed points is a perpendicular bisector. So you first mark the 2 points A, B, and then you have to construct the perpendicular bisector. So you first connect A and B point with a straight line and take the compass and construct the perpendicular bisector. So here take a certain distance more than half of AB. You can mark an arc above and below. Again keep on top of B and mark arc here and below. Here you have to redo this again because we can't see the intersecting point. So we'll extend this line. Okay, now we can see the intersecting point. Take the ruler and connect. So this is the perpendicular bisector. So this is the wall. The path of the fire of a torch held by a fire torch rotating dancer in a perera, while the fire torch rotator is stationary. So here that means a circle. So here what you have to do, this is the stationary point and you need to draw a circle. So you take the radius as this length. So take the distance there as the radius and draw the circle. So here the path of the fire of torch held by a fire torching rotating dancer in a perera. Here this is the stationary point. The path of a person riding a Ferris wheel. Ferris wheel also goes round and round. So this is the center and this is the radius of the Ferris wheel. So here if you know the center point, you take the compass and take the radius as the length of this wire here to here and draw a circle. So here these are the chairs. Here around this it goes like that. The paths of the two children riding a seesaw while sitting at the two ends of the seesaw. Now think about, this is the seesaw, and here in the middle is this point, fixed point. So we'll take the compass and find out the midpoint. Now if the seesaw is 10 centimeter length, or we'll take a certain distance first. We'll take 8 centimeters. Okay, so this is the length of the seesaw. Here to here. So this is the seesaw. And here you need the midpoint as well. So for that, what's the distance to the midpoint? That's 4 centimeters. So we can mark 4 centimeter point. So this is the fixed point. Okay, so here I'll mark it. This is the fixed point, and here two children are on this point and this point. Now what happens in a seesaw? It goes up and down. So here, so like a circle. So here you can draw half arc like this to represent it goes like this. Here to here and here to here. So the paths of the two children riding a seesaw while sitting at the two ends of the seesaw is something like this. Question number 2. In the given figure, P and Q are two trees planted on flat ground at a horizontal distance of 25 meters from each other. It is required to fix a tap at a distance of 15 meters from each tree. With the knowledge on loci, draw a rough sketch to indicate how the points where the tap can be fixed. We'll take a scale. So we can take 10 meters, 1 centimeter, or we'll take a smaller one. 5 meters represent 1 centimeter. 5 meters represent 1 centimeter. Then what about 25 meters? 25 meters means 5 centimeter length. Then we need 15 meters as well. So 15 meters is what? 1 over 5, 15 divided by 3 centimeters. So you have to draw a 3 centimeter length. Now we'll take that one and draw the sketch. So we draw the 25 meter length first. So we can mark one tree P. To that tree you can mark the 25 meter length. So that means 5 centimeters. So we'll take 5 centimeters from here and mark the other tree. So this is the other tree. So that's Q. So PQ tree, that's 25 meters away. Now 3 centimeters means 15 meters from each tree. Now we'll take the compass and take 3 centimeters. So from each tree, 3 centimeters away. So we can check, we can draw three centimeter circle like this, and also 15 meters away from the other tree. That means 3 centimeter length. So we'll draw another. What can you say about this? Now the tap should be with the equal distance, 15 centimeters away. So where you need to fix the tap, because this is equal distance, this place and this place. So here, if you put here inside, that means one distance is less than the other. So where you need to fix the tap, either this point or this point. So tap, here another tap you can fix. So when you take the distance from here to here, that's 15 meters, that's 3 centimeter length. This one, it is required to cut a drain equidistant from the trees. Draw a rough sketch to indicate the location of the drain. So this is same as before. So equidistance from these two trees means you have to draw the perpendicular bisector. So how you draw the perpendicular bisector? Assume that this is PQ line and we'll draw the perpendicular bisector. So take any distance more than half of this and draw an arc above and below, and keep the compass on top of point Q and draw the arc below and above. Here you need to extend the line. Here do it again, keep it here and extend this line. Okay, now you can see the intersecting points connect with a ruler. So I can connect this point and this point with a ruler. So you can cut the drain along this line. So this is the drain. Question number 3. Draw an angle of 50 degrees and name it as PQR, as shown in the figure. With the knowledge on loci, draw a rough sketch to indicate how the point which is equidistant from the points Q and R and lying on the arm PQ is found, and name it S. So you have to now draw 50-degree angle. Can you use the compass? No. Certain angles only you can use the compass for certain angles. So here you have to use the protractor to measure 50-degree angle. Now we'll draw a line there. That's QR. So I can mark this point is Q and this is R. Length is not given, so you can take any length. And here 50-degree angle you have to measure. So take the protractor and measure 50-degree angle. So where is 50-degree angle from here? This point. Now you can draw a line from P to this one. So this is P. Now we have 50-degree angle. Now where is S? It says draw a rough sketch to indicate how the point which is equidistance from the points Q and R. So equidistance from Q and R means the perpendicular bisector to Q and R and lying on the arm PQ. So when you draw the perpendicular bisector, the intersecting point of PQ arm and the perpendicular bisector is the S point. So we'll do that now with the compass. Take any distance more than half of this and draw an arc above and below. Again, keep on top of point R. Draw the arc below and above. Here again, we can't see the intersecting point clearly, so make sure that you draw it properly. Now we have the two intersecting points connected. Connect it with a ruler. So we'll connect this point and this point. That's the perpendicular bisector, equidistance to Q and R. Now the point S is on the PQ arm. So S is somewhere there. Take fourth question. A and B are two lamp posts located at a distance of 10 meters from each other. It is required to fix another lamp post C at a distance of 6 meters from A and 8 meters from B. Mark the location of the lamp post C on a suitable rough sketch. So here you need to take a scale first. So 10 meters. So here we'll take 1 meter represent 1 centimeter scale. So 10 meters means 10 centimeter. And 8 meters you need, that's 8 centimeters. This is equivalent, or you can put a ratio sign to represent this is a scale. And 6 meters I can put here colon sign, also 6 centimeters. Then we need to first mark the points A and B. So we'll take, this is the line, ground here, and A point is here. So take the compass and the ruler and you need to measure 10 centimeter length. So take 10 centimeter length and mark it here. That's the B point. That's 10 meters away from each other. Then from A, the post P, from A, the post C is 6 meters away. So take the compass and measure 6 centimeter length. And here from A you can draw an arc somewhere there. That's 6 centimeter length. Now take 8 centimeters and mark from B. Eight centimeter length and mark from B. So here keep on top of B and you can mark the other arc. So the intersecting point is the C point. Because here to here 6 centimeters and here to here 8 centimeters. So the post C is here. Now we'll take the second part of that question. It is required to fix a lamp post D, equidistance from the post A and B. Mark the location of the lamp post D on a suitable rough sketch. So here I'll assume that this is the length of AB with 10 meters and the lamp post D is equidistance from the post A and B. So that means midpoint of these two. So if these two is 10 meters, what's the distance from A to the midpoint D? 5 meters away. So here what I can do, I just take roughly the midpoint. So we'll take roughly, what's the length here? Here, this is the length. It's roughly 11. So half of it. So half of it is 5.5. 5.5, somewhere here is the middle. So what you can do, you can mark the midpoint of these 2 points. That's the point D. So this is the lamp post D, equidistance from A and B. And you can write this is 5 meters from here and this is 5 meters. Example number 1. OP and OQ are 2 roads which diverge at the junction O. It is required to fix a notice board at a point which is 20 meters from the junction O. So here if you sketch this diagram, this is the junction O, 20 meters distance at an equal distance from both these roads. That means you draw the angle bisector and from here 20 meters away from O. Using the knowledge on loci, indicate by a rough sketch how you would find the place where the notice board should be fixed. So that means angle bisector. So what you do, you take the 2 roads if the 2 roads are like this, OP and OQ, you draw the angle bisector. So how you draw the angle bisector? You take certain distance, draw an arc on this arm and this arm and take the same distance or longer distance, doesn't matter. You draw an arc in the middle. Here also you draw an arc in the middle. And the intersecting point connect with the O point. And then what you do? You measure 20 meter length. We'll say we measured it already. 20 meter length. Keep on top of O and mark the point. So this is where you need to fix the notice board. So what it called? Notice board. So this is where, so 20 meters from O and It is on the angle bisector. So I'll write this is the notice board. Exercise 14.2. Draw a straight line segment and name it XY. Illustrate by a rough sketch the locus of points which are 4 centimeters away from it. So, what's that? This is the line XY. And then 4 centimeters away from that. So you need to draw 2 parallel lines on both sides of XY. So how we draw 2 parallel lines? So we can use equal distances from any 2 points and connect it. So for that we need the ruler and the compass. Measure 4 centimeter length. And here we can mark 4 centimeter length arc somewhere here and somewhere here on the other side as well. So we can change the side and mark. You can take any point on the line and draw an arc here 4 centimeters and again take any point on the line and mark the 4 centimeter. Now you can take the ruler. What you do, you can keep it here. You can keep the ruler on top of this one and see. You need to touch both arcs. So this is fixed. First I'll fix this point. It's easy to fix this point and then rotate this one so that you get the other one. Here you can use this or Z square also possible. I'll show you with the Z square as well. Now you can draw the line. Here we select the line and draw it. This is the parallel line to XY 4 centimeters away. And here also you can take the ruler and connect, these 2 arcs, touches, and then you can draw the line. These 2 arcs touches, and here take the ruler and draw the line. Now if you are using the Z square, how you draw the 2 parallel lines? Take the Z square and first keep on top of this XY line. Here, keep on top of XY line and you can measure 4 centimeter and mark it here. Again, take somewhere here and mark the another 4 centimeter point and then connect it. Other side also like that. So if you are using other side, so you can take this way. So here you can keep the z square this way to draw the other 4 centimeter line, and then mark the 4 centimeter point and then draw it. So that way you can draw the 2 parallel lines to xy with the distance 4 centimeters. Here 4 centimeter, this is also 4 centimeters. Question number 2. A student walks on a straight road, rotating a wheel of diameter 20 centimeter which is fixed to a handle. Illustrate by a rough sketch the locus of the center of the wheel. So here, think about, this is diameter 20. Diameter 20 means, what's the radius? Here, diameter 20 wheel. So this is the diameter 20 wheel here. This is the wheel. So what's the radius there? 10 centimeters. A student walks on a straight road rotating a wheel. So this goes round and round, which is fixed to a handle. So this is the handle. Illustrate by a rough sketch the locus of the center of the wheel. So center is here. So handle fixed to this point. So now we can sketch it. 20 centimeter means 10 centimeter is the circle radius. So we can take the compass and the ruler. Take 10 centimeter length. And then you draw the circle. So this is the wheel. And the center is here. Center is here. And the handle is fixed to that. So think about, this is the handle, this is the handle, and what's the radius? Radius is 10 centimeters. So what's the path of the wheel? Locus is a circle. So this is the point P on the wheel. The figure shows the positions of the hour hand and the minute hand of a clock at a certain instant. At this moment, the second hand is located at an equal distance from these two hands. Indicate the position of the second hand by a separate rough sketch. So here, roughly, what's the angle here? If you take this clock 360 degrees for the whole thing. So how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 360 divided by 12, you get 30 degrees for each number, the gap between each number. So how many gaps are there? 1, 2, 3, 4, 5. 5 times 30, 150 degrees. So that means they are asking the second hand is in between. That means angle bisector of 150 degrees. So how you draw 150 degrees? How can we draw 90 and 60? 90 degree and 60 degree, you get 150 degrees. So we can use that method to construct the path. So what we can do, I'll draw a line, that's this hand, and mark the point here This is the center. And I need to draw 150-degree angle to this point. So what I can do, I can take the compass and draw 90-degree angle first. Take certain distance. Mark this arc and onto the other side. Arc, and then take a longer distance to this and draw the arc above to this point. So I'll draw an arc above here and another one here to get the intersecting point. Then I can connect this point with here with a broken line, because you need 150, not 90. I'll connect like this. That's 90-degree here, this side and this side. Now we need another 60-degree towards right side. How you draw a 60-degree angle? You can take the compass, take any distance. I'll take a smaller distance so that I can mark it clearly. So I'll take this distance and take somewhere here and draw an arc. Again, same distance, I keep it here and draw the other arc. So that's 60-degree angle. So 90 plus 60. Is this correct? No. You have to draw 60-degree angle to this side. So you need to take the compass again and mark take any distance, mark it here first. Take any distance here and then another arc somewhere there. Here, again keep on top of this point. Here, and draw the other arc so that you get the intersecting point. Now we have the intersecting point. So we can connect this one with a ruler. So here this is 60. So this point and this point, I'll take a line here to here. Now we know this whole angle is 150. 90 plus 60, you get 150. So this is the other hand. Then the second hand is in between that. Now we'll construct the angle bisector. Take the compass and here keep here in the middle, take certain distance and draw an arc here and on the other arm here. Then take a bigger length or the same length. You can use it. You can draw an arc to this side and keep on top of this one and draw the other arc. The intersecting point, and this point you connect with the ruler. That's the second hand. So that's in between, equal distance to our hand and the minute hand. So that means this is 75 degrees here. This is 75 degrees and 75 here, this one. Question number 4. A drain PQ of length 50 meters, which is located in a certain plot of land, is shown in the figure. A tap needs to be fixed at a distance of 10 meters from PQ and at an equal distance from both the ends P and Q. Illustrate by a rough sketch the position or positions where the water tap can be fixed. a drain PQ of length 50 meters. So here if we take PQ is the drain 50 meters length. A tap needs to be fixed at a distance of 10 meters from PQ. PQ 10 meters, so it can be here or here. 10 meters away from that. From both the ends P and Q. So either this one or so you have to draw two parallel lines. So we'll draw two parallel lines to this. So how you sketch it? Take the compass and here we'll take 50 meters. So 1 meter or 10 meters, 1 centimeter. We'll take a scale. We'll take a scale. 10 meters is 1 centimeter. Then 50 meters means 5 centimeter. So the PQ length is 5 centimeter. So you take PQ line and here mark one point P and measure 5 centimeters and mark the other point Q. So you can mark the other point Q. So these are 2 points P and Q. That's 50 meter length. Now we'll try to draw the two parallel lines 10 meters away. 10 meters means 1 centimeter away. So here we can use the compass. Take 1 centimeter and measure here and draw the two parallel lines, or you can use the set square. So set square, you can keep on top of this line and mark 1 centimeter length. So here measure 1 centimeter length and mark it here, and again keep on top of this and mark 1 centimeter length again. And then keep the ruler and draw the line. Do the same thing. Now you have to do it other way around as well. So here you can keep on top of this and mark 1 centimeter here and again 1 centimeter here. Now you can draw the two lines. So connect with a line here to here. That's the parallel line 10 meters away from PQ, and connect these 2 points as well. Now again it says the tap is equidistance to P and Q. What's equidistance to P and Q points? That's the perpendicular bisector. So here what we do, take the compass. Now we'll try to draw the perpendicular bisector. Take a certain distance, more than half of it. Draw an arc above and below. And also keep on top of Q and draw the arc below and above. And and on the other side. Here you need to again redo it this side because we can't get the intersecting point. So here extend this line. Now we get the intersecting point. Now connect with the ruler this point and here. This is the equidistance from P and Q points. Now, where's the tap now? You can fix the tap here or here. Two places are there. So, tap 1, T1 and tap 2. So, this is equidistance to P and Q. That's the perpendicular bisector, as well as 10 meters away from the PQ line. So, this is 25 and 25 because PQ length is 50 meters. Take question number 5. A piece of cake cut from a round circular cake is shown in the figure. It is required to divide this piece of cake into 2 equal pieces using the knowledge on loci. Indicate by a sketch how this piece should be cut. So this is an acute angle. So you need to take the angle bisector. So think about the cake is something like this piece with a sector. Here we can just take the compass and take certain distance. Here we'll say this is the length of the cake. Here this piece is there. So we need to divide this into 2 parts. So angle bisector. So take the compass and keep here and take any distance. Draw an arc here to this arm and to this arm. Then again keep on top of this. Draw an arc in the middle and arc in the middle as well. Then connect this one with a ruler here to here. Now we see these 2 are the pieces that you get equally divided. So this is angle bisector. So this angle is equal to this angle. Question number 6. PQ and PS are 2 boundaries. PQ, PS are 2 boundaries of a rectangular plot of land. A tree needs to be planted in this plot of land such that it is 8 meters from the boundary PQ and 5 meters from the boundary PS. Illustrate by a rough sketch where the tree should be planted and name it T. So it says 8 meters from the boundary PQ. So you need to draw a line here 8 meters away from PQ. And 5 meters from the boundary PS. From here 5 meters. So here 5 meters. And a tree needs to be planted here. There, this is the intersecting point of the 2 lines. That's this point. So tree should be planted here. Now here I have already a scale here. This is 15 centimeters, that means 30 meters. So here I'll take 15 centimeters. 15 centimeters represent 30 meters. 1 to 2 scale. 1 to 2 scale. So this is 20 meters there. So how many centimeters I have to take? How many centimeters I have to take to show that's 8 meters? So 8 meters means this is 4 centimeters from here. And how many meters from this place? 5 meters. 5 meter means this should be, what's the value? Divide by 2. So 2.5 centimeter represent 5. Divide by 2. 5 divided by 2. Now we'll take the compass and the ruler, measure 2.5 centimeters. From here. So we can mark from here 2.5 and also from here 2.5. I'm trying to draw the parallel line. Now connect here to here. That's the line 5 meters away from PS. Now we need to draw 8 meters away from PQ. So 8 meters means 4 centimeters. Take the compass and 4 centimeters from here. And you can draw a line here from here. So from P, here mark 4 centimeters away here, and from Q also 4 centimeters away, and connect the 2 points here to here. That's the distance here. What's the distance? 8 meters, and here to here 5 meters. Now it says the intersecting point is the point where the tree should be planted. So here tree should be there. Now look at exercise 14.3. Draw a straight line as shown in the figure and name it as BC. Construct a perpendicular line from the point A to the line BC. So think about, this is the BC line. Now you have to draw a perpendicular from A. So how you do? Take the compass and you take any distance from here. Take any distance and you can mark 2 arcs intersecting with the BC line. So here you can draw 2 arcs like this, and then take the compass again. Take a length, no need to be the same length. Take any length. From here you draw an arc below, and to this point also you draw an arc. The intersecting point and the A point you connect with the ruler. So this is how you can draw a perpendicular line from an outside point A to BC. Draw the line AB such that AB is 7 centimeters. Mark the point P on AB such that AP equals 3 centimeters. This is 3 centimeters and AP is 7 centimeters. And construct a line perpendicular to AB through P. So we'll take the ruler, draw a line and mark the point A. Use the compass and the ruler and measure 7 centimeter length and mark the other point. 7 centimeter length and mark the other point. That's AB. Now this is the B point. 7 centimeters away from each other. Now we need to mark P point. AP is 3. So take the compass and measure 3 centimeter length. 3 centimeter length from here this length you keep on top of A and mark the point P. So this is P point. Now you have to draw a perpendicular to AB from P. So we take the compass, take any distance from P, smaller distance. I'll take a different color here. Now draw an arc on this side and to the other side. And take a bigger length. Keep on top of this intersecting point and draw an arc above here and keep on top of this point and draw another arc here. The intersecting point and the P point connect with the ruler. So that's the perpendicular drawn from P to AB. Question number 3. Draw any acute angle triangle and name it PQR. Construct a line perpendicular to QR from P. Construct a line perpendicular to PR from Q. Construct a line perpendicular to PQ from Q. So you can take any acute angle triangle. Something like this. This is PQR. PQR. Now we have to draw a perpendicular to QR from P. So from P. So what you do? Take the compass. Take certain distance and see where it cuts the line QR. So here I'll take a longer length so that I get here somewhere here. Okay, draw an arc here and arc there. So I need to extend this line. So I'll do that first. So I'll extend this line here. This is the QR line. Now we got this point. Now take the compass and you can take certain distance here. And mark the two arcs. So I'll take a bigger length so that it's easy. So I can mark an arc here and keep on top of this point an arc here. Here it's not intersecting, so that I have to again redo this arc. Here I have to connect. Now I can see the intersecting point. Now connect. this point and this one with the ruler. So that's the first one. Perpendicular to QR from P. So this is the perpendicular. Then construct a line perpendicular to PR from Q. So we need to draw a perpendicular there. PR from Q now. So where's the Q point? Q point is here. So PR line is here. I need to extend this line because it's difficult to get the intersecting point. Okay, now we'll try to do it. Take the compass. I'm taking a different color now. Now we have to draw the perpendicular line from Q. So take any distance and you need to keep on top of Q and draw two arcs. So we'll take a bigger length. So here, one arc here and another arc here to this line Q, to the PR line. Now take the same distance from here or a smaller distance, okay. So you can draw an arc here and here to this point. So that's the intersecting point. Now connect Q with that line. Q with this point. Now connect Q with this point. So here I need to take the ruler. Take the ruler, connect this point and Q point. That's the perpendicular line to PR from Q. That's the second one. And the third one, construct a line perpendicular to PQ from R, from this point. Take the compass. We'll take another color. I'll take red color. Now from Q. So take any distance from Q. Keep on top of R and draw an arc on top of PQ line like this, and again another arc here. And we have now two intersecting points. Keep on top of this one and draw the below arc. Arc here and arc to this side. The intersecting point is the line. So here R and this one is the perpendicular line to PQ. So this is the PQ perpendicular from R. Question number 4. Using a protractor, draw an angle of 130 and as shown in the figure, mark 5 cm on each arm and complete the triangle XYZ. So 130 degree angle. So what you do, take the ruler, draw a line, and here you'll mark this one is Y, and you need 130 degrees. Take the protractor now because we can't construct 130 degree angle from the compass. So here just take the protractor . 130 degrees. So 130 degrees this way. So here, somewhere here, mark it and take the straight line and connect this point. That's 130 degrees. Now we need 5 centimeter length. Take the compass and the ruler. Measure 5 centimeter length. And mark the 2 points. That's here Z, and the other point is X. So 5 centimeter from here, that's Z. Here 5 centimeter from here, that's X. And you can connect the 2 points and complete the triangle XYZ. That's the XYZ triangle. Construct a perpendicular line from Y to the line XC and name the point at which it meets XC as D. So take the compass, take any distance, and I'll take a different color now. Take any distance from here, and you need to mark 2 arcs on XZ, here and here, here and here. Now take the same distance or different distance, doesn't matter, and you can draw the arc here and arc here. Now connect, you get the perpendicular drawn from Y to XZ. So this is 90 degree. The point is D. Measure and write the lengths of XD and ZD. So take the compass to measure, because you can't keep a ruler there and measure, so always take the compass. XD here. We'll take here, keep correctly here on top of this line and see here this point. And we can take the compass here on top of the ruler and you can measure the length. What's the length? 4.4 centimeters. So it says XD is 4.4 centimeters and ZD again, keep it there. From here roughly, it's the same. Here you can see it's the same. So 4.4. So DZ or ZD is also the same length, 4.4. Construct a rectangle of length 6 cm and breadth 4 cm. So you need a line and mark any point. Now you need to measure 6 centimeters and mark the arc. So here 6 centimeter, measure it, 6 centimeters. Keep on top of this point and mark it at 6 centimeter length. Then the breadth is 4 centimeters. So you need to draw a perpendicular line along this one, because rectangle, all angles are 90 degrees. So to do that, you take the compass, take any length here, and you can draw an arc to this side and to this side. Again, an arc to this side and to the other side. And take a different length now. Take a different length and mark arc here and here. Again, keep it here and mark the other two arcs so that you can draw the perpendicular lines. Now, we can connect it and draw the two perpendicular lines. And now we have to measure 4 centimeter length using the compass. 4 centimeter length and mark on these perpendicular lines. So I can take a different color. I'll take blue color and here this point and this point. So 2 points are there. Now take the ruler and connect it. So I can connect these 2 points. So I'm now getting the rectangle. What's the length? 6 centimeter one side and the other side is 4 centimeters. So these angles are 90 degrees. Take this question. Draw a straight line segment PQ such that PQ is 10 centimeters. So here, take the ruler and the compass. You need 10 centimeter length. So we will first draw the straight line and mark the point P. Take the compass, measure 10 centimeter length and mark it. So this is PQ line with 10 centimeter length. Mark the point B on the line PQ such that PB equals 2. So you need to measure 2 centimeter length. And mark the other point. So this is B point. So PB is 2 centimeters. Construct a line perpendicular to PQ through B. So we need to construct a perpendicular. For that I can take the compass, take any length, draw an arc here and to the other side and keep on top of this, take a bigger length and draw arc here and onto the other side. And here you can connect this with a ruler. So this is the perpendicular drawn at B. Now what's the next one? Mark a point A on the perpendicular line such that BA is 6 centimeter and complete the triangle ABQ. So we need to measure 6 centimeters. and then mark it on this line, perpendicular line. So that point is A. So this is A. Now you can complete the triangle BAQ. So this is BAQ triangle or ABQ triangle. Construct the perpendicular bisector of the line segment BQ. So perpendicular bisector of the line BQ, and the name the point it meets the AQ line as O. So we need to now construct the perpendicular bisector. How we draw that? Now take the compass to draw the perpendicular bisector. Take any distance from here, more than half of it. Draw an arc above and below. Again, keep on top of the Q point and draw the arc below and above so that you get the two intersecting points. Now you can connect this one with a ruler. So that's the perpendicular bisector of BQ and the intersecting point of AQ line, and this is point O. That's this part. Construct a circle with O as the center. O is the center and OA. OA is the radius. So take the compass, A point here, and OA is the radius. So here somewhere here, this one. So OA is the radius and you need to construct the circle. Now we'll see. We'll draw the circle. So what you get? The circle passes through A, B, Q points. So this is the center, O, and OA is the radius. So here we can see OQ is also the radius. Exercise 14.4. Draw a straight line segment of length 8 centimeters and name it PQ. So take the ruler, draw any line and mark P. PQ length is 8. So you need the compass to measure PQ length. So keep on top of the ruler and measure 8 centimeter length. Keep here and draw the arc. Now we know this is PQ with 8 centimeter length. Now we need to construct 60-degree angle. So take the compass, 60-degree angle at P. So keep on top of P, take any length, draw arc here and arc somewhere there because 60 is below 90 degrees. So here, keep here and draw another arc. Now this is 60-degree angle. Draw the line. So this is 60. Now construct an angle 60 at Q such that QP is an arc. So we have to draw another 60 here. So take the compass again. We need 60 to this side. Take any distance, draw an arc here an arc somewhere there. Again keep the compass here and draw another arc and connect it. You get 60-degree angle. You get 60-degree angle here. So here 60-degree angle here as well as 60-degree angle here. And this is the intersecting point of the two lines. So that's all you have to do. Draw 60-degree angle to P and Q. Question number 2. Draw a straight line segment of length 6.5 cm and name it AB. Take the ruler and mark one point, that's A. Measure 6.5 centimeters and mark the other point B. 6.5. So mark it here, that's point B. 6.5 centimeters. Construct an angle of 90 at A such that AB is an arm. So here you need to draw a 90-degree angle. So you need the compass, keep on top of the point A, take any distance, smaller distance is enough. Mark this point and on the other side mark another point, then take a bigger length and mark above to this point and another arc here. The intersecting point and the A point connect with the ruler. So that's the perpendicular. Construct an angle 30 degree at B such that BA is an arm. So here you need to construct 30-degree angle. So you can do 60-degree angle and bisect it. So you can take certain distance, draw arc here and another arc somewhere there. Take the same distance and mark the arc, you get 60-degree angle. So we need 30-degree angle. So we'll take the broken line and mark it. That's 60-degree angle. Now you need to bisect it. Take the compass. Here you can take these two arcs and take another length, certain length. Keep on top of this point and draw an arc here. Now I am drawing the angle bisector. Here also keep it and draw this arc. Now I can connect B point and this intersecting point, that's the 30-degree angle, angle bisector of 60. So this is 30, this is 30 and this is 90. Produce the constructed line so that they intersect. Name their point of intersection as C and form the triangle ABC. Question number 3. Construct angles of magnitude 15 and 75. So how we construct 15? You can bisect 30-degree angle. First construct 60 degrees, bisect it, you get 30 degrees. Again bisect it, you get 15. And 75, you can do 90 and 60 bisecting 60, you get 30, 30 bisecting 15. So 60 plus 15, you get 75. So we'll first construct 15-degree angle. So mark a point here and then take the compass and construct 60-degree angle. Take a certain length, draw an arc here, another arc there, keep the compass here and draw it here. You get 60-degree angle. So you can take a broken line and connect it because we need 15 and not 60. Now bisect this. You can keep here, take any length. Bisect here and here. And again, this is 30, broken line. We need to bisect 30 again to get 15-degree angle. So take the compass, take certain distance, draw arc here and arc here, and take the same distance or bigger distance. You draw an arc in the middle, and here also you draw an arc. And the intersecting point of these two is the 15-degree angle. So you can connect this point and this one. So that's 15-degree angle. So this is 15. Now we'll try to draw 75-degree angle. So 75, what we can do, you can do it here. We can draw 90-degree angle first and 60-degree angle already there, and then we take the bisectors. So 90-degree angle, how you construct? Take the compass. To this point you can draw a perpendicular. For that you can use certain distance, draw an arc here, an arc to the other side, and take a longer distance and draw an arc above here and here. Now connect these two with a broken line. You get 90-degree angle. Now see, this is 90, this is 60. So what's this angle? 90 minus 60, 30. So we'll bisect 30-degree angle. So how you bisect 30-degree angle? Take the compass, take any length, draw arc here and here, and take the same length or different length and bisect the angle. So you can draw here and keep the compass here and draw the other arc. Now you can connect the two intersecting point and this one. That's 75. So here this angle is 75 degrees and this angle is 15. So what did we do? 90 and 60 in between we can bisect to get 15-degree angle. Question number 4. To construct the triangle shown in the figure below, do the following construction. So here you have to construct this triangle. So we'll first sketch it and see what they ask. Draw a straight line segment of length 7 centimeters and name it PQ. So we need to label it PQ. Construct an angle 30 at P, 30 degrees at P, such that PQ is an arm. Construct an angle of 45 degrees to Q at Q, such that QP is an arm. This is 45, and complete the triangle PQR and measure and write the magnitude of PRQ. PRQ. You have to measure this one. So you need to get 180 minus 45 plus 30. What is the angle you need to get? 75. So you need to get an angle of 105. So you might get a closer value to 105. Now we'll construct. Take the ruler, draw a line and mark the point P. Use the compass and the ruler and measure 7 centimeter length. And mark the point Q. So this is Q point. What's the distance? 7 centimeters. Now we need to draw 45 and 30. So take the compass. First we will draw 60-degree angle and then bisect it to get the 30-degree angle. And arc here and arc there. Here, keep it here and draw an arc. That's 60-degree angle. We need to bisect again. So keep the compass here and bisect it. So you can draw an arc somewhere there. Keep on top of this point and draw an arc here. Here, the intersecting point. Connect with P, that's the 30-degree angle. This is 30 degrees. Now you need to construct 40-degree angle to this point. Draw 90 degrees and bisect it. Take the compass. Take any distance. Draw an arc here and arc onto the other side and take long distance and take longer than that, and here you can draw the arc in the middle and arc here. That's 90 degrees. Now we need to bisect 90-degree angle. So this is 90-degree angle. Now bisect it. You need the compass. Keep on top of Q point. And you need to draw 2 arcs. One arc here and here another arc. Take the same length. Keep on top of this point and draw the arc in the middle. And here again take this compass to this point and draw the other arc. Here. Now we can connect to get the 45-degree angle. So this and this point, you get 45-degree angle. So this is 45. Now we have PQR triangle. Now we need to measure this angle. So take the protractor to measure this. So we'll keep the protractor on top of this point, R point. Here, and you need to measure this angle from here. Other way around, here, what's the angle? 75 this way. This way 75 means 180 minus 75 this way. So what is 180 minus 75? I get 105. So the angle PRQ angle is 105. So that's what we need. It's correct. Question number 5. Draw a straight line segment OA of length 10 centimeters. So this is 10. Draw an arm BO such that AOB is an obtuse angle. Okay, so we need to measure the length. So we'll take any length here. We take any line, mark the point A. Now we need to measure 10 centimeter length. So keep the compass here and we need to measure 10 centimeters. Centimeter length from A. So that's point B. So this is AB 10 centimeter. Now draw an arm BO such that AOB is an obtuse angle. Doesn't matter, any obtuse angle means more than 90 and less than 180. So I can draw any obtuse angle and I can mark this as B. Mark the point P on OA. This point is O and this point is A. This is O and this is A and this is B. Now next one, draw an arm BO, that's obtuse angle, we did that. Mark the point P on OA such that OP equals 7. So take the compass and measure 7 centimeter length now. 7 centimeter length. So here this is 7 centimeter. Keep on top of O and mark the point P. So this is P. This point is P. Now, so this length is 7 centimeters. Now we need to do the next part. Construct a line segment PC such that C is on the same side of OA as B and such that APC angle and AOB angle both are equal. So that means you need to draw a parallel line along P to OB. So how you draw a parallel line? We can take the compass and here we can measure this length. Take this length. So this length and the length from B should be the same. So that's what we have to do. So we'll do it from here. We take 7 centimeter length here, and if the point is here, B is here, you can mark the point. That's also 7 centimeters. And you can, this is 7, and you can again clearly get the point by taking a certain distance. From here, we'll take O, we'll take any length here. I'll drag this, and here, yeah, somewhere here, I'll mark this point, and here again keep on top of this point, and I have to mark it. Or I'll take a bigger length. So take any length, so I'll take a bigger length somewhere here. I'll take this length. Yeah, somewhere here. Take the same length here and draw an arc. I can draw this arc. The intersecting point of this and this, you can connect it. That's how you can construct the parallel line. So I use the method of a parallelogram. Two lengths are equal, opposite sides are equal. Now take the ruler and connect P and this intersecting point. So that's the C point. So this intersecting point is C. Now we can see APC. This angle and this angle both are equal, corresponding angles. If the two lines are parallel, corresponding angles are equal. Question number 6. Draw any acute angle and name it KLM. So any acute angle. I can draw any acute angle like this and mark KLM. KLM. Copy the angle L at M such that KLM is equal to LMN. So this angle is same as here. So how we copy an angle? So you can take any distance from here, from the point. You can mark it here, and you can mark somewhere there. So you do the same thing to M point, to this side. So you take the same distance from M and mark arc here and arc in between. And then what we do, we take the distance from here to here. So this point to this point. We take the distance from here to here. So that's the angle size, and copy that here. So we take the compass and mark the same size angle. Now we get the same angle. Now this is the same angle. So this angle and this angle both are equal. where N is the same side of LM as K. So L, M, N. So here we can mark any point N here. We'll mark N here. L, M, N. Name the point of intersection of the lines LK and MN as P. Now here intersecting point is here. Intersecting point is P. Produce the lines if necessary and measure and write the lengths of PL and PM. So we need to measure this. Now if this angle is equal to this angle, this is isosceles triangle and these lengths should be the same. We can check whether our diagram is correct. So take the ruler and see what's the length of PL. So here, this is the length. Now we'll see what's the length there. Keep on top of the ruler and we'll measure. What's the length? 9.2. So we got PL 9.2 centimeters. What about PN now? So we'll measure it from here, from P. Here you get the same length. Look at that. Here when you keep it properly, here you get the same length. So it's exactly the same length. So you can write PM is also 9.2 centimeters. Miscellaneous exercise. In a factory, a 15-meter long arm of a crane is fixed to a groove of length 20 meter. So this is 20-meter length. It can be moved along the groove and also rotated in a horizontal plane above the end points. So here and here you can rotate it. Draw a rough sketch and indicate with measurements the path on the horizontal plane where the crane can exchange goods. So basically it means this is the 20-meter length. 20-meter length groove, and here 15 meters it can move. So that means a horizontal line. Horizontal line means parallel to this one. You get another parallel line 15 meters away here and here. So this is 15 meters length and another 15 meters length. And this one is 20 meters. And at the end point, what it says, it's rotating, can rotate. So you get a semicircle like this here and another semicircle like this, so that the radius of this semicircle is 15 meters. This is 15 meters and this here to here, that's 20 meters. So what's the path of the crane? So it goes like this. And also we need to mark these two are parallel, because 15 meters away from this line, the line is parallel to this one. Question number 2. To construct the triangle shown in the figure, carry out the steps given below. Draw a straight line segment PQ where PQ is 5 centimeters. Construct an angle 90 at P. Construct an angle 60 at Q. Complete the triangle PQR and measure and write the magnitude of R. So we need to construct it to find out the magnitude. So take the ruler and draw a line and mark the R point. This is R. And what's the PR length? We don't know PR. We know PQ length. So that means we can draw the perpendicular line. So here draw this line and mark P point. Measure 5 centimeter length. And you can mark the Q point below. This is Q. So this is 5 centimeter. This is Q. And then you have to construct an angle of 90 degrees at P. So you have to construct a perpendicular. Take the compass. Take any length. Take certain distance and draw an arc here and arc on the other side, and then take a longer length, keep on top of this point and mark this arc and the other arc on this side, and you can connect P and the intersecting point. That's the perpendicular line. So this is 90 degrees. What's the next one? You need to construct 60-degree angle to this one, to this line at Q. So take the compass again. Take certain distance. Now you have to draw 60-degree angle to this point. So take any distance, mark the point here and somewhere there in between, and keep it here and draw the other arc. Now you can connect this one with this one. That's 60-degree angle. So this is 60. Now what we have to do, this is the point R, and you have to measure and write down the R angle. What you should be getting? You need to get 30 degrees. This is 90, this is 60, means this should be 30. So we'll check with the protractor. So you take other way around and measure this small angle. So keep on top of this. Keep it properly on top of. Now it's okay. So what's the angle? So you need to keep it somewhere there. So this is roughly, this is 32 something. So slightly we made a mistake. So the exactly you need to get 30, but my diagram like 31. So it doesn't matter because these are constructions. So you can write R is 31 degrees roughly. Question number 3. As shown in the figure, draw an obtuse angle ABP. So you have to just draw something like this. So this is an obtuse angle. A, B, P. Locate a point K such that A, B, P. So this angle and such that the two angles form a pair of alternate angles, ABP and BPK. So alternate angles means you have to draw a parallel line to this. So this is BPK. The two angles form a pair of alternate angles. Join PK. So here basically what you have to do, you have to draw a parallel line to AB along P. So this is a rough sketch. Question number 4. Draw a circle of radius 4. So we'll do that. Take the compass and the ruler, measure 4 centimeter length. You have to first mark a point O, that's O. Keep the compass on top of O and draw the circle. So this is 4 centimeter radius. So this is the circle with radius 4 centimeters. And then mark 2 points A and B on the circle 6 centimeters apart. That means you take the compass and mark 2 points 6 centimeters away. That means you take this length. First you mark any point here. Keep on top of this and you can mark the other point. So then this is 6 centimeters. So we'll mark it. This is A and B. So this length is AB. Draw the line AB. Now connect A and B point. That's this. Construct a perpendicular line from O to AB and name the point at which it meets AB as N. So construct a perpendicular. Take any length. And get two intersecting point from O to AB, this point and another point here. Now take the compass and you can take any length and find out the intersecting point from A and B. This is the intersecting point. Now connect O with that point, intersecting point. That's the perpendicular drawn from O to AB line. And the point here is N. Measure and write the lengths of AN and BN. These two lengths. We'll measure it and see. Use the compass. AN equals, we'll keep on the ruler and see, 5 centimeters. Now we'll measure BN, that same distance, 5 centimeters. So you get the same distance AN and BN. So we covered all theory related to loci and constructions. So we discussed the locus point on a plane which are at a constant distance from a fixed point. It's a circle. So you get a circle from a fixed point. The locus of points which are equidistant from two given points is the perpendicular bisector of the line joining the 2 points. If there's 2 points, the perpendicular bisector is this one, equidistance from 2 points. The locus of points which are at a constant distance from a straight line are the two straight lines parallel to it and at the given constant distance from it on either side of it. So that means if there's a fixed line, you can draw two parallel lines with a fixed distance. And the last one we discussed about the locus of points equidistant from two intersecting straight lines is the angle bisector of the angles formed by the intersection of the two lines. If you get two straight lines and intersecting point, the equidistance from here is the angle bisector. So these are really important because you are definitely getting one question for your O-level exam. So we are doing constructions again in grade 10 and 11. So practice all these methods.